Okay guys, so this video will show you questions 1 through 5 from the test review, okay? So let's go ahead and get started. Number 1, it says, which is an element of the range, okay, of the graph function? We know that these are y values from domain and range, which means we're looking at these kind of values here. And if I concentrate on looking at where they're located, here's 3, here's a 4y value, here's a 2y value, and here is a 0y value. So it says which is an element, that means which one is a piece or belongs in the set of the range. So obviously you see that it's 0 because there's in fact 2 places where it exists. So the answer would be D. Alright, so let's go to number 2. It says for which function is 3 not an element of the range? So there's that y value again. So we're looking at when is y equal to 3, but when is 3 not an element of the range? So if we were to graph these individually, let's go ahead and start with this one. We know it's mx plus b. The y-intercept, of course, is 4, so we would start 2, 3, 4, and the slope is negative 2, so it's down 2 over 1, down 2 over 1, down 2 over 1. So it looks something like this. And we want to know when 3 is not an element of the range. Well, obviously 3 is an element of the range because there's y equals 3 and it's touching the graph. So it's not A. If we were to graph x to the 5th, it would look something like this. Okay? So x to the 5th is going to have, actually, let me just show you with the calculator because I might actually be a little wrong there. Let's go to the calculator. And we're going to press 1 for new document, 1 to add a calculator page. We're going to do Control Doc to add a page, and it's going to be 2 because it's a graphing. And we're going to put x to the 5th. So x to the power of 5. So this is actually what it looks like. So it is cubic. I thought so. So looking at this, if you were to ask yourself, is 3 an element of the range? Okay, so is 3 an element of the range of what we just saw? Well, here's 3, and we know it's actually hitting the graph right here. So we know it's not going to be that one, because 3 is an element of the range. Okay, so it's not B. And then if we were to graph y equals 3, well, y equals 3 is the line that we've been drawing, essentially, and it's always the element of that range, so we know for sure it's not C. And then last but not least, I'm going to show you with and without the calculator. Okay, so this one right here, if you take negative x and you square it, it's the same because of that 2 as having 2 of these written down. If it was negative x to the 3rd, it'd be 3 of them written down. Okay, with 2 of them written down, we know that a negative times a negative is a positive, so this becomes positive x squared. But we still have to account for this negative PEMDAS-wise. So after this becomes a positive x squared, it goes right back to negative because of that piece right there. So what you're really graphing is y is equal to negative x squared, okay? Which is going to look like this shape right here going downward. So 3, y equals 3 is way up here, and you see that it never crosses or even touches this graph. And we're looking for the not, so D would be the answer. Okay? Alright, so is the relation, so it's not necessarily saying it's a function, it's just saying that these are points. So by looking at this first one, 4 maps to 8, you see 7 going to 11, 10 goes to 14, and 12 goes to 10. So if you were to quickly sketch it, you could do this to see if it passes the vertical line test. 1, 2, 3, 4, let's say 8 is about up here. Then 5, 6, 7, let's say 11 is about here. Oops, a little bit more to the right. And then 8, 9, 10, 14 is about here. And then 11, 12, 10 is about here. So you see it passes the vertical line test. So is it a function? It would be yes. Another way that you could have seen this is that no x maps to 2 different y's. So if you see like 4 going to 8 and 4 went to 11. Graphically, 4 going to 8 and to 11, so there's 11 right here, it would fail the vertical line test. So if you see an x is repeated, otherwise maps to 2 different y values, it would be no, because it would fail the vertical line test. But again, because you don't see that here, the answer is A. Let's go to number 4. So number 4 has 4 graphs, and it's asking, do any of the following represent a function? So we were just checking to see, do any of the following pass the vertical line test? Well, a vertical line test, this would definitely fail the vertical line test. This one would fail the vertical line test because it hits 2 points right here and here, right there at that vertical line. And this one too would fail the vertical line test. The only one that passes the vertical line test, if you were to move this vertical line left and right as you scroll through the graph, something like that, would be this bottom function right here. So B would be the one that represents a function. And the justification is because it passes the VLT, the vertical line test. Let's go to number 5. Number 5 is a word problem, and it says a bucket has 16 inches of water in it. Okay, so imagine a bucket, if you will. Okay, and there is 16 inches of water. So let's say that that's about here. Okay, so here's our bucket of water, and just to visually see it, this is 16 inches. But there's a hole on the bottom. So over here at the bottom, let's say that there's a hole and it's leaking water out. Okay, get a little creative with my little picture here. Use an interval notation to write the domain in range of the function h of x is equal to 16 minus 1.25x. Okay, so what does x and what does h of x represent? That's what we're going to be looking at. X is the time the water has been leaking in minutes. Okay? And h of x is the height of the water in inches. So we can say by intuition that h of x being the height, it's going to start when at 16 inches. That means at 0 time, so let's say when x, which is time, when time is equal to 0, the height is going to be at its most maximum, which is 16 inches. And that's like saying h of 0 is equal to 16 inches. Okay? So, and as time goes on, we know that time can't go negative. It's got to go positive. But it can start. It can start at 0. So it's not going to be letter B, because this one says it's not starting at 0. It's starting right after 0. We know it's not D either. So the reason why we know it can start at 0, it has to be a closed bracket. So it's either going to be A or C. So the other piece that we're going to look at is the range. Okay, and the range is saying the range will be from 0 to 16, but not necessarily in that order. Obviously from this you see that from the bucket it's going to start at 16, but then it will end up decreasing and so on and so forth, and where you don't have a length as far, or a height as far as water being left. So that's what would get you to that 0. So C would be the correct answer. You can check if you want by plugging in this 12.8 into x, and if you do, you'll see that 12.8 times 1.25 will end up becoming 16. So 16 minus 16 obviously would show you that at time 12.8 seconds, it would go to this 0 y value that we were talking about, that 0 height. But at time 0, at the beginning of this, you could say event or whatever of the water leaking, it would be at height. The only reason why they have it written from 0 to 12.8 is because we are writing domains least to greatest, the same with ranges. So C would be the answer.